welcome to another episode of the Pharmaceutical Calculations Solve Along. In this video, we're going to take a look at the smart and easy way to solve concentration waters type dilution calculation questions. And by the time we are done, you'll be really good at dealing with this type of questions. Now, this video series, or this video actually was inspired by this particular question from one of our active viewers. But before I go ahead and solve that question, I just need to give you some background on what concentrated waters are, and then we'll go into this question and add 3 more examples to make the video more beneficial to everybody. So when you talk about concentrated waters, you're actually talking about stock solutions. So these are stock solutions, and their primary purpose is to be able to dilute them to produce single strength and double strength waters. So the question that actually would immediately come to mind is, what exactly is single strength and double strength? So single strength refers to a situation where you have 1 part of concentrated water to 39 parts of water. Now, an example or examples of concentrated waters would be peppermint water, rosewater, and chloroform water. These are very good examples of concentrated waters. Now, a single strength is when you have 1 part of the concentrated water to 39 parts of water. So if you had 1 milliliter of concentrated peppermint water, then you add 39 milliliters of water to form a single strength. Now, the other way to capture that information is 1 part of the concentrated water in a total of 40 parts. And you get that 40 by adding the 1 in the previous example. So if you added this 1 to the 39, you end up with a total of 40. So that's where this 40 is coming from. So 1 part in 40 milliliters, 1 ml of concentrated water in 40 milliliters total. That would be another way to capture the single strength. Now, we've dealt with single strength, but what exactly is double strength? But before we do that, it's important to understand that when you have a single strength, the relationship between the concentrated waters and the single strength is a 40 times relationship. So your concentrated water is 40 times more stronger than a single strength water. Okay. Now, all this information that I'm presenting right now is something that you really need to have stenciled in your mind, because we'll be drawing upon this rich information set to solve the questions down the line. Now, when we talk about double strength actually implies that you have 1 part of the concentrated water to 19 parts of water. So once again, the example will be if you took 1 milliliters of concentrated rose water, then you would need 19 milliliters of water. And that would imply that your total parts would be 20. So the other way to capture that is you have 1 part of concentrated water in a total of 20 parts. Okay, so here again, the relationship between your concentrated water and your double strength water is one of a 20 times relationship. So your concentrated water is actually 20 times more stronger than your double strength water. So these are information you want to have stenciled in your mind. The question that would normally come to mind is, what then is the relationship between a single strength and then the double strength? Okay, so that relationship is you have a situation where your double strength water is 2 times as stronger, or 2 times stronger than your single strength. Okay, and what that would actually imply is that if you wanted to make a single strength water from a double strength water, then you need 1 part double strength water to 1 part of water. Okay, or the other way to capture that is 1 part of your double strength in a total of 2 parts. Now, this information forms the basis for all the calculations that we'll be doing, and similar ones that you see down the line in your career. So I want you to just take a mental picture of this, or maybe perhaps take a snapshot, write it down, and then we'll go ahead and look at the question that we just got from the viewer, which would be our first question, and then we'll go through 3 more examples to illustrate the various ways in which you may see questions of this particular nature or fashion. All right. Now, by the way, if you have questions and you're watching this video live, then you can ask your questions in the chat box. And if you are watching the replay, just leave your questions in the comments and I will address them as soon as I see them. Okay. And if you're liking this kind of content, this live session, just click the like button or leave a subscribe or something, right? So that people can benefit from the video as well. But let's get right to the question. So here the question says that what volume of concentrated peppermint water is required to make 16.8 liters of single strength peppermint water. Okay, so the first thing we want to do is identify the key information here, and we have concentrated peppermint water. Okay, and we want to make this volume, but we want to make a single strength. Now in this question, we're fortunate they gave us exactly the relationship between single strength and then the concentrate, which is 1 part to 39. But what we want to do actually is first, to make things easier, convert the liters to milliliters. And so let's do that, and then we'll proceed to the next step. So once you understand really what this is about, the solution is very, very easy. Okay, that's why I said the smart and easy way. So let's convert the 16.8 liters. We convert that to milliliters. And we recall that 1 liter is 1,000 milliliters. So the liters cancel out, and you end up with 16,800 milliliters. So that's the volume we want to make. Okay. Now, what we are going to do is, just to give a reminder, we are going to draw information from actually what is happening in terms of your relationship between the double strand and the single strand. Okay, so what I mean by that is, if you look in this particular snapshot of all the information that you need, your concentrated water is actually 40 times stronger than your single strength. So that information is the same as 1 part of concentrated water to 40 parts of total quantity. So this information is actually what you are going to use to solve that question. Okay, so I just felt it's important to remind you where that is coming from. So when we go back to the question, what it would imply then is, if we took 1 part of the concentrated peppermint water, then we will need to make a total of 40 parts of the solution. Okay, but we can set up a proportion in such a way that we do know the total volume we want to make, so that would also go in the denominator. So you have your 16,800 milliliters right here, and then in the top, or in the numerator, we want to determine the volume that is needed of the concentrated peppermint water. So the proportion would allow us to do that. And so now the way you want to do it is simply go ahead and solve for your unknown, which is x. So x is going to be equal to 1 times 16,800 milliliters divided by 40. And you end up with 420 milliliters. That's it. Really simple, straightforward, right? But the reason it was easy at this point is because we remembered some of the information that we've talked about in the beginning, that the relationship between the concentrated peppermint water and the single strength is a 40x relationship. Okay, and so that's what we did right here. We set up a proportion using that ratio. Okay, now I don't see any questions in there, but I do see, I think, BJ Emon saying hi. So hi to BJ Emons as well. All right. Now let's go ahead and look at another example. Okay, so this example kind of worked itself out very nicely, but let's look at another question. So here the question is saying how much concentrated rose water is required to make 250 milliliters of double strength rose water. Okay. Now the key thing to identify is you're starting off with concentrated rose water. You know the volume you want to make, but it's a double strength, not a single strength this time. So in the previous example that was single strength, here you have double strength. All right. And so what we really want to do is understand the relationship between concentrated rose water and the double strength. And once again, I'm going to pull that previous slide. And what we are going to use this time is the information pertaining to double strength. All right. So we know that 1 part of concentrated water should be in 20 parts total. Or in other words, you have a 2 times more concentrated preparation, a 20 times more concentrated solution when you have a concentrated water compared to the double strength. And that's the information we are going to use. So we're going to go back to the question. And that's why I said that slide was very important. You want to capture that information really nicely. And we are going to make use of that information. So if it's a 20 times and it's a 1 part to 20 parts total, then what we can say is 1 part of concentrated rose water go with the 20 parts total. And we will set up a proportion at this point in time and then say that how many milliliters would we need to then make 250 milliliters. So just to reinforce the concept, once you know those rules, then everything falls down into a very more or less trivial proportion. So now here again, we can go ahead and solve for x, which is our unknown. X equals 1 times 250 milliliters divided by 20. And that gives 12.5 milliliters. So that will be the answer. So there's a very excellent question that I see in the chat from Richard. He says, at what point will you use the original proportion 1:39 parts? So we'll take a look at a question that is similar to that in the next question. So let's just take a look at that question. It's not really the 1:39, but there's something similar, and that would illustrate when you would use it, or a good time to use that kind of information. So the third question is actually how much water needs to be added to 45 milliliters of concentrated peppermint water to produce double strength peppermint water. So here we are going to actually indirectly address the question that was asked by Richard. And that is at what point in time do you use the 1 to something and not 1 in something? All right. And this is a useful question to illustrate that concept. So here you want to pay a little bit closer attention because this question is slightly different from the other two that we've done. It's asking how much water needs to be added. Okay. So here we are looking for water, which is your diluent. In all the other examples, we're interested in the amount of concentrated water. Here we just need the diluent, and we are adding to some volume. So these are keywords that you really want to pay attention to. And we are making a double strength. All right, so double strength. So here, if we go back to our reference slide, double strength would imply that we are actually looking at this piece of information. Okay, one. We are looking at this piece of information. So here, we are going to use the information of 1 part to 19 parts, which is more or less similar to the question that was being asked in the chat box. We are interested in 1 part of something to something, right? So we are going to find out that this 19 parts gives us the information needed to compute the volume of water to add. That's what this portion allows us to do, okay? And so we're going to go back to the question and make use of that information, okay? So here, what we are going to do is we are going to say that if you have 1 part of your concentrated peppermint water, then you actually need 19 parts of water. So just note the difference. In the previous examples, we're actually using the ratio of 1 to the total parts because we had information on the total quantity we wanted to make. Here, we are just interested in the volume of diluent, so we take 1 part to the 19 parts of the water that we want to add. Okay, so now we set up the proportion, and the question is, this 45, does it go in the numerator or the denominator? Now, since we are adding water to this, so this is the concentrated portion, then that goes in the numerator. So your 45 milliliters will be here in the top, the numerator, and the denominator will be the total. Okay, I mean, the denominator will be the volume of the water that you need to add. Okay, so if we solve for this x, that will give us the answer to the question. So x will be equal to 19 times 45 milliliters divided by 1, and that gives us 855 milliliters. All right, so the statement to have stenciled on your mind is, whenever you actually are asked to determine the volume of water you're going to add, then you use the 1:something. It's the fastest way to get the answer. But when you've been given the total quantity, then you do the 1 in something. Okay, so just to reinforce that again, I'm going to go back to that slide and we'll take a look at the information. You want to note the prepositions in those statements. So you have to and you have in. In is when you have the total volume or total quantity. To is when you need the parts of water. That's a handy trick or handy way to capture that information. Okay, so that was the third question. And then the last question, let's take a look at what the last question actually is. So here the question says a formula calls for 2.5 liters of single strength rose water and 150 milliliters of double strength peppermint water. You only have double strength rose water and concentrated peppermint water. How much of each should you use? Okay, so here let's start off with the single strength portion. So we are going to make 2.5 liters of that, and we are going to use a double strength solution. So first of all, let's just convert the liters to milliliters to make the computation much more easy and consistent across the solutions. And we recall that a liter gives us 1,000 milliliters. So the liters cancel out. And of course, we end up with 2,500 milliliters. All right. But here's the kicker. The question is, what's the relationship between double strength and single strength? That's what we need to recall. Okay. And so once again, I'll refer you to this important slide. And the information we are using this time is what's in the bottom here. Okay, so because we actually have the total volume that we are interested in, then it's more expeditious to use this version. All right, 1 in something, because we have the total parts and we have the total quantity that we want to make. Okay, so after some time, this should be more or less second nature, and you don't need to reference the slide that frequently. But having said that, since we know it's a 1 in 2 parts, then we know that for every single part of the double strength, you end up with 2 parts of solution. Okay, and then we can then set up the proportion and say, well, how many milliliters do I need if I want to make 2500 milliliters? We saw for x is going to be equal to 1 times 2500 milliliters, and that will be divided by 2, and then you end up with 1250 milliliters. So that will be the answer for the first part. That's for single strength, so let's just put that somewhere. So this is for single strength. Now, let's take a look at how you would solve the same question for the situation where you have the concentrated peppermint water. Okay, I'm just going to give a fresh. All right, so for the double strength, let's use a different color for that. What's actually going to end up happening is we need to recall the relationship between a double strength and concentrated. And we've done an example, and we know it's a 20 times relationship. So for each part of the concentrated peppermint water, you're going to end up with 20 total parts. So that's the relationship that we want to recall. And then we can set up the proportion now. So how many milliliters of the concentrated peppermint or water do we need to make 150 milliliters total? Okay, so we can go ahead and solve for y, which is our unknown. So y equals 1 times the 150 milliliters divided by 20, and that will give you 7.5 milliliters. All right, so I don't see any questions in the chat box. I think understanding is there and really clear. But that's how you actually solve these type of questions the smart and easy way. It all depends on making sure that you truly understand what is going on this particular slide. And if you capture it, then every other kind of question you come across, you know how to use that information to solve the problem. And just to reinforce the concept, you want to pay attention to the prepositions. I can't say it I can't emphasize it too much. No, the difference between to and in. That's very important. All right, so I'm going to stop here, and then if you have any more questions right now, you can leave them in the comments if you have the questions later. All right, so I hope you found this video tutorial useful. If you'd like to just jump onto this kind of live session, then either subscribe or click the notification bell, and I will see you in the next video.